Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on transformations of the plane. In the last lesson, we learned about a type of transformation called reflection. Today, we will learn about another type of transformation called rotation. Are you ready, students? We will begin. Rotation is a type of transformation in which figures turn around a point called the center of rotation. If the angle is positive, the rotation runs in a counterclockwise direction. It is a rigid motion. A rotation around a point through an angle is a transformation of the plane onto itself, which carries every point P of the plane into the point P prime of the plane. It is such that OP is equal to OP prime and the angle POP prime equals theta. O is the center of rotation, and theta is the angle of rotation. Let R be a rotation through angle theta about the origin. If coordinates x and y are subjected to rotation r, then we can calculate x prime by finding the difference between x times the cosine of the angle and y times the sine of the angle. Y prime can be calculated by adding x times the sine of the angle and y times the cosine of the angle. It sounds complicated, but students, it is actually very simple. Here is point A, located at 1, 0. If we wish to rotate A 30 degrees about the origin, the resulting image looks like this. Do you remember your lessons from trigonometry? The coordinates are equal to the radius times the cosine and sine of the angle, as we see here. A is equal to 1 times the cosine of 30. B is equal to 1 times the sine of 30. Therefore, A is equal to the square root of 3 over 2. B is equal to 1 over 2, or 1/2. Therefore, the image of point A has coordinates of the square root of 3 over 2 and 1 over 2. The transformation we just carried out is expressed this way. We have just performed our first rotation. You see, students, that rotation is not too difficult. Using the formulas, find the image of this point after it has been rotated about the origin. Please go ahead now, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. Let us compare our answers. Here is the formula that we must follow. X prime is equal to negative 4 times the sine of 30 degrees, which is negative 2. Y prime is equal to 4 times the cosine of 30 degrees, which is 2 times the square root of 3. Therefore, the image of a point at 0, 4, is at negative 2 and 2 times the square root of 3. I do not imagine you had much trouble with this exercise, students. Here are a few facts about rotation around the origin. Let R be a counterclockwise rotation through an angle about the origin. If the angle is equal to pi over 2, or 90 degrees, x and y become negative y and x. If the angle is equal to pi, or 180 degrees, they become negative x and negative y. If the angle is equal to 3 over 2 pi, or 270 degrees, they become y and negative x. If the angle is equal to 2 pi times any integer, the rotation is the identity transformation. Here is another rotation, students. Please apply this rotation to a point at coordinates 3 and 1. See if you can locate the image. I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again. How did you manage this problem? Here is how we find the reference angle for 450 degrees. It is 90 degrees or pi over 2. X prime is equal to 3 times the cosine of pi over 2 minus the sine of pi over 2. This is equal to -1. y prime is equal to 3 times the sine of pi over 2 plus the cosine of pi over 2. This is equal to 3. Remember, students, the rule we just learned. Because the rotation is pi over 2, x and y become negative y and x. Therefore, the image of the point is located at negative 1 and 3. So far, we have discussed rotation about the origin. Let us now look briefly at rotation about an arbitrary point. P prime is the image of P after it has been rotated through angle theta about a point at coordinates x, 0, and y, 0. In that case, we can use these formulas to find prime P. Take a moment to copy these down, students. As an example, we will find the image of a point at 0 and 1 after it has been rotated 45 degrees around a point at 2 and 3. If we use the formula that we learned a moment ago, we can substitute the values to make this equation for x prime. Performing the correct calculations, we find that x prime is 2. By a similar calculation, we find that y prime is 3 minus 2 times the square root of 2. Therefore, the coordinates of the point's image are 2 and 3 minus 2 times the square root of 2. We have learned how to calculate rotation around an arbitrary point. We have just enough time for one more activity. Please find the image of a point at 1 and 3 after it has been rotated 300 degrees around a point at 2 and 0.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Did you do well with this problem, students? If we use our formulas, we can substitute the values to find x prime. We find that x prime is 3 plus 3 times the square root of 3 over 2. We can also use our formulas and substitute the values to find y prime. We find that y prime is the square root of 3 plus 3 over 2. We can see an illustration of this idea here. Here is our point A. Here is the point of rotation, B. Point A rotates 300 degrees about point B. It comes to rest at 3 plus 3 times the square root of 3 over 2 square root of 3 plus 3 over 2. That is all for this lesson, students. We have learned about rotation, about both the origin and the arbitrary points. Until next time, thank you, teacher. Thank you, students.